Close your eyes.
Hard pill to take when somebody says that satellites could be fake. But don't you find it a little suspicious that you can't find any real satellite pictures? It might be hard to be believed, but maybe we're all being deceived. Yeah, maybe, Listen up. Well, if you think you've seen one up in the sky, you can't see it with the naked eye. Because a satellite is about the size of a car, at least 300 miles away. You can't see that far, whatever those dots are to move in the night. I'm telling you, there ain't no satellite. Welcome to the satellite, folks. Just another one of them NASA jokes. You can't buy me a picture of a satellite without bringing up a bunch of that CGI. Just a bunch of cartoons all over the place. When I search satellites in space. Yeah, type that phrase into Google, folks. Let me welcome you to the satellite host. Now, before all of y'all start getting pissed, I ain't saying that satellites don't exist. I'm saying that it's theoretically absurd to think these devices orbit the Earth. Cause I've seen them hanging from big balloons. Even Google's doing it too now, man. Have you seen that? Yeah, go check out Project Moon. And every now and then a satellite crashes, but that information never gets to the masses. Cause then you'll find out how these things really work. They're just on balloons, man. They don't orbit the Earth. Cause once upon a time, one crashed in Brazil with the balloon attached to it still. Welcome to the satellite, folks. Just another one of them NASA jokes. You can't buy me a picture of a satellite without bringing up a bunch of that CGI. Just a bunch of cartoons all over the place. When I search satellites in space. Yeah, type that phrase into Google, folks. But let me welcome you to the satellite host. Yeah, check it out, man. How could satellites be in the thermosphere when the temperature up there is way too severe? How can that type of equipment survive? How comes those satellites aren't burned alive? I'm telling you, man, it's just a pack of lies. There ain't no orbiting satellites because 99% of our communication comes from undersea cables and cell tower stations. A GPS is ground-based too, man. Go check out a system called LORAN. It's a military system for navigation that uses ground towers to track your location. Are you seeing it yet? Welcome to the satellite, folks. Just another one of them NASA jokes. You can't buy me a picture of a satellite without bringing up a bunch of that CGI. Just a bunch of cartoons all over the place. When I search satellites in space. Yeah, type that phrase into Google, folks. Let me welcome you to the satellite host. You see, Tesla figured out how to communicate without the need for satellites in space. It's mostly ground-based towers, you see, and that's how you get your satellite TV. They've monetized what Tesla made for free with their fake satellite industry. It was Arthur C. Clarke that theorized these things, the sci-fi boxes with solar wings. Another Freemason, it's no surprise. They make science fiction and they monetize. They've stolen Tesla's technology and they get you to pay for your TV. Are you seeing it now, people? Welcome to the satellite, folks. Just another one of them NASA jokes. You can't buy me a picture of a satellite without bringing up a bunch of that CGI. Just a bunch of cartoons all over the place when I search satellites in space. Yeah, go type it into Google right now. And let me welcome you to the satellite hoax. So next time you see a photo of the Earth from space, look for satellites. You won't find a trace. Well, they must have disappeared, I guess. Can't even see any from the ISS. If you want to have yourself a little enjoyment, go watch a NASA satellite deployment. Oh, man. Well, let me welcome you to the satellite hoax.
It's one of the best-kept secrets of space science. For transporting ambitious and hefty scientific experiments to near space. Though they're not as flashy or headline-grabbing as rockets. For the quickest and most cost-effective trip to near space, they are the time-honored gold standard.
Satellite missions can take 5 to 7 years and millions of dollars to develop, where scientific balloon instruments can be developed on a shorter time frame and much lower cost.
From atmospheric studies to the origins of the universe, they have been the vehicle of choice for some major scientific discoveries. And new superpressure technology, along with sub-arcsecond pointing capability, put scientific balloon performance on par with satellites for certain types of science. An Austrian prince named Victor Hess is a key figure in understanding where scientific balloons have come from and how they're evolving. Hess loved hot air balloons and physics. In the early 20th century, he combined his two passions in making a series of daring high-altitude flights above 17,000 feet. The aim was to measure high-energy particles in the atmosphere. His discovery of cosmic rays landed him the Nobel Prize in Physics in 1936. He was also the pilot of the first scientific balloon. Fast forward to the end of World War II and a man named Otto Winzen. He devised a way of sealing thin polyethylene film with load-bearing tape. His helium-filled balloons made it possible to fly very large and heavy payloads.
And he got a patent on that in 1950. And those early balloons were so large, they didn't have any way to launch them, except they actually launched them from aircraft carriers.
Modern scientific ballooning was born. The first spacesuits and other pioneering technologies designed for the space program were flown and tested on high-altitude scientific balloons. With the modern space program now at the forefront, Winzen's balloon became a workhorse for carrying large scientific payloads to the edge of space. These balloon-based experiments began to train generations of young scientists, including one named John Mather. Mather's early experience on scientific balloons would help pave the way for his groundbreaking work on COBE, the Cosmic Background Explorer satellite. COBE's measurements of cosmic microwave background radiation would help to seal the Big Bang Theory, and ultimately win Mather and his colleague George Smoot the 2006 Nobel Prize in Physics.
Stephen Hawking said it was the most important scientific discovery of the century, if not of all time. And a few years after that, we got the call to go to Stockholm. And so, tremendously important result of the balloon program.
Individuals can have a part in every stage of the process.
John Grunsfeld former NASA Associate Administrator and astronaut, worked on scientific balloon payloads while earning his PhD.
The first time I saw a balloon launch, helium was in the bubble, it was on the spool opened up, and I heard the rustle of the polyethylene and saw it rising, and then the balloon took off and off it went. I thought, this is just the coolest thing ever. I went on to do 3 Hubble Space Telescope servicing missions. And for that, it was much more like scientific ballooning, because there was a moment where I was inside of the Hubble Space Telescope, this time in a spacesuit, working with tools, reaching inside of the Hubble, and I had a flashback right to that moment on the flight line, reaching into my balloon gondola. And the thought that I had at the time was, all of those lessons that I learned in building the payloads, preparing them for flight, was preparing me to go service and upgrade the Hubble Space Telescope.
And scientific balloons have been responsible for some significant Big Bang Theory breakthroughs in their own right. The temperature of the cosmic microwave background was first measured to be 3 degrees Kelvin by balloon-borne experiments. Exactly the temperature it was predicted to be 14 billion years after the Big Bang.
And we also measured the slight temperature difference in different directions of the cosmic microwave background, which is caused by our motion through the universe. And both of these measurements done from balloons confirmed the Big Bang Theory.
And unlike orbital, satellite-based missions, balloon-borne scientific payloads can be recovered and flown again.
I'd rather have a science balloon than a science satellite. With a balloon, there's no need for rockets. To get a satellite to hover over the same spot on Earth, geostationary orbit, you have to be 36,000 kilometers away, too far to use some sensors, like radar. A balloon can sit 1,000 times closer, in the stratosphere, 30 to 40 kilometers above the Earth, and still be above 99% of the atmosphere with clear views of the stars or wide panoramas of Earth. You can bring down a balloon, tinker with onboard scientific equipment, and then launch again. Satellites, not so much. Cost is also a factor. NOAA's 4 new geostationary weather satellites are estimated to cost $11 billion, whereas a balloon flight might cost just a few $100,000. NASA's been flying balloons for a long time, but without any steering capabilities, they drift in the wind across continents. Now, private industry is getting in the balloon game, with new technologies that are enabling balloons to hover over one spot. These balloons rise and fall in the stratosphere, catching countervailing breezes that allow them to stay roughly in the same place. What can a balloon with a scientific payload do? It can look down at the Earth, checking on storms or animal migrations. It can look out into space, peering at the surface of the sun or collecting cosmic rays. It can even do things in the stratosphere, like studying how ice crystals could reflect sunlight and cool the planet. How do you keep a balloon stable enough to use a telescope? Gyroscopes can help keep a platform pointed at its target, even as it sits in a twisting gondola. But this isn't an ad for scientific balloons. There are a few caveats. For example, while satellites last for years, the longest balloon flights have been a few months. And what goes up needs to come down, so most balloons come with parachutes that can bring their payloads down gently.
Hi Chris, thank you so much for joining us.
Thank you for having me.
So you're part of NASA's balloon program. What is the difference between a NASA scientific balloon versus a regular hot air balloon?
Good question. So hot air balloons are air-filled, and the air is heated to create the buoyant through the lift that gives them flight. Generally, they float at a couple thousand feet, and they go up and down in a matter of hours. Scientific balloons, on the other hand, are quite different. So our largest balloons can fit a football field inside their equator, and they can fly for much longer. So payload capacity is about 8,000 pounds, several SUVs. The duration can be up to 5 or 6 weeks at a time, and the altitudes can be up to 160,000 feet, about 4 or 5 times the height of a commercial airliner.
Wow.
So quite a bit different, yeah.
That's incredible. And you launch all over the globe. So you launch from New Mexico in the US, New Zealand, and even McMurdo Station in Antarctica. Why do you launch from all those different places?
In short, we go where the science needs us to go. Some scientists need Northern Hemisphere science for galaxies and star formations. That's why we go to Sweden. Same thing in the Southern Hemisphere. That's why we go to Antarctica. Most missions need some kind of trial or test system, so they'll fly from New Mexico to prove their science or even just collect science at a shorter duration. And then for missions that are a little more risky, we'll go out to PMRF in Hawaii.
So can you describe to me what launch day is like?
It's an incredible feeling, right? So you see the balloon be released, you hear the rustle of the fabric and the rush of the wind as it stands up. You see the balloon be released from the vehicle and ascend, and it just gives you chills every time you watch it. It's a really great feeling.
That sounds incredible. So how many of these balloon experiments have been sun-focused or eclipse-focused?
So about 8 to 10% of our portfolio is heliophysics missions. One of the ones that stands out in my mind is one I got to see launch in 2019 from New Mexico. It's called the BITSI mission, and it was looking at the corona, or the kind of the outer edge of the sun, and looking at how that behaves under different conditions.
That sounds amazing. Now, let's learn about some discoveries made by NASA's balloon program.
High above Earth's surface floats a critical tool in NASA's exploration arsenal: scientific balloons. Massive, helium-filled, high-tech balloons lift heavy scientific experiments into near space to get a clear view of our planet and the cosmos. Launched around the globe, these unique NASA missions provide a fast and cost-effective alternative to rockets to study Earth, our solar system, and beyond. Balloon science has led to many important discoveries. For example, astrophysicist John Mather studied heat from the early universe using balloons, which later contributed to his Nobel Prize-winning work confirming the Big Bang theory of an expanding universe. A special type of high-altitude balloon can carry telescopes above the clouds for extended periods of time to study the dark matter in distant galaxy clusters. One of these superpressure balloons, called SuperBit, captured the Tarantula Nebula 160,000 light-years away. This winter, crews in Antarctica are preparing to launch the Gusto mission. Its infrared telescope will examine the complete life cycle of a star. NASA's scientific balloon program, guiding a path to discovery above and beyond.
In 1957, the Soviet Union launched the world's first satellite into space. Since then, about 8,000 satellites have been launched. To begin making a satellite, a technician works on the internal computer that serves as the brain of the satellite, ensuring constant communication with the Earth. Circuit boards are created and double-checked by a worker. These proprietary circuit boards are a crucial component to making a satellite function. A robot makes high-tech maneuvers behind a metal cage and pre-assembles the heavier sections of the satellite. More than 800 man-hours go into making a satellite. Satellites are used for many purposes. Common types include military and civilian Earth observation satellites. Also, there are communications, navigation, weather, and space-based satellites. Space stations and human spacecraft in orbit are also considered satellites. Once the satellite is built, a team prepares to launch it. Workers attach a balloon to the main components of the satellite and fill the balloon. The balloon, or better known as a satellite, is now ready for liftoff into space. I mean the atmosphere. They release it into the sky. Above each city, there are thousands of satellites. I mean balloons. I mean satellites, creating a somewhat seamless GPS network, working in harmony with ground-based towers and undersea cables. After an artisan creates a digital painting of a satellite, a programmer then writes a complex algorithm that controls Google search results, making sure when people search for flat Earth, they only see what Google wants them to see. The programmer then uploads the digital rendering to Google's hard drive to complete the process.
Communications, banks, stock exchanges, hotel reservations, cable TV, hospitals, computer centers, and other new customers are appearing at an increasing rate. We are in the midst of a global communications explosion. Helping meet this demand are communications satellites.
This is President Eisenhower speaking. It is a great personal satisfaction to participate in this first experiment in communications involving the use of the satellite balloon known as ECHO. In this first experiment in communications involving the use of the satellite balloon known as ECHO. Involving the use of the satellite balloon known as ECHO.
August 12, 1960. President Eisenhower took part in the historic first transmission via ECHO satellite. By bouncing radio waves off its shiny surface, it made possible long-distance telephone conversations. Bouncing radio waves off its shiny surface. It made possible long-distance telephone conversation. By bouncing radio waves off its shiny surface, it made possible long-distance telephone conversations
involving the use of the satellite balloon known as ECHO.
Long-distance telephone conversations, and the transmission of photographs and music. Other communication satellites followed. Telstar,
the Discoverer 17 satellite is launched into north-south orbit from Vandenberg Air Force Base, California. After more than 1 million miles and 31 passes over the Earth's poles, a capsule is released over the Pacific, where a flying boxcar waits to grapple the descent chute. A miss on the first try, but the second makes the connection. This recovery completes the most successful test in the Discoverer program. It is the first in which the rocket engine of a satellite was restarted in orbit, in itself a major stride forward in space technology.
Some of NASA's latest space dreams came crashing down in Central Australia today. A giant helium balloon packed with expensive scientific instruments lost its moorings in high winds. As Anna Henderson reports, it cut a swathe through an airfield and sent onlookers running for their lives.
As the giant helium balloon was launched into the air, its precious cargo became a high-speed projectile. Unexpected strong winds pushed the 2-ton platform of scientific instruments off course and onto a path of destruction. Justin Trotter's car was tipped over. He can be seen here running for his life.
They started losing control of the payload. We started to move the cars and just barely made it out without getting smashed.
The couple sitting inside their vehicle right next to his car can barely believe they survived.
There was just lots of noise and we really thought we were gone.
It was just an instance of chaos outside. We were expecting to be wiped out.
While Justin Trotter was inspecting the damage, NASA scientists were picking up the pieces of years of work. It's not clear whether anything can be salvaged.
Everybody is feeling very down about it. A quick look showed that there were bits that were in pretty good shape. But to be able to expect that to be put together within a month for another launch seems unlikely.
The Glad-wrap thin, giant balloon came down in a nearby field and will be thrown away. The balloons are launched into the stratosphere carrying cutting-edge telescopes that help give astronomers and scientists a much clearer view of space. Organisers say they are relieved no one was hurt.
We're very particular at the balloon launching station not to see this as a circus and invite people to come and watch the launches simply because of the risk factor.
One balloon was successfully launched earlier this month, and NASA is adamant it will have another ready for takeoff shortly. But after today's events, spectators will be told to stay away. Anna Henderson, ABC News, Alice Springs.
Rocket design failure blamed for Galileo satellite mislaunch.
An investigation by launch service provider Arianespace shows that fuel freeze caused the Galileo satellite launched in late August to enter into a lower orbit than planned. A Soyuz rocket carrying 2 Galileo satellites was launched from French Guiana at 9:27 a.m. on August 22nd. The fairing, a cone which protects the payload, was shed after the rocket entered into space due to the reduced friction as anticipated. The first and second stages also detached from the rocket without a hitch. A design flaw, however, caused the fuel powering the frigate stage to freeze. The hydrazine nozzle was blocked as the fuel supply pipe was placed too close to low-temperature helium pipes. The satellite was placed into a lower orbit than planned. Lacking sufficient fuel, the satellites are not expected to make it into their pre-planned orbit.
Grande sapo, viu? Eu sou um que tá mandando. Não, mas não vai só a luz. Não, isso aí vai sair mais não, cara. Lona tem muita aí, cara. Lona e lona pra quem quiser aí. Quero só da cor. A conta pra botar no caminhão, ó. Isso aí não tem internet. Não dá pra cortar essa de jarra, mas tá aqui.
Launched in 2012, the first 2 years of Project Loon were a process of rapid iteration. The team had to prove it was possible to deliver reliable internet access to specific locations in the most remote parts of the globe. They began with the simplest possible approach, electronics stuffed into a styrofoam beer cooler floating at the edge of outer space. When that didn't fail, they kept moving forward.
The way Google X works is we try to prove that it can't work. So the first thing we did was took a router, flew it on a weather balloon up to 10 kilometers and see if you could still get a signal. And that part worked. And since then, it's been a continuous process of trying to stretch the envelope a little bit more every time to see how far it would go.
Last year, the team made a critical decision, switching from a wireless router to an LTE antenna.
We are just like a cell phone tower, but in the sky. And the same way that their central office of the telco interacts with all their cell towers, they will interact with our balloon. Another way to think about it is if you drive down the highway on a phone call, you will switch between cell towers. What we're doing is kind of flipping that on its head. So you're standing still on the ground with your LTE phone. And as one balloon goes overhead, another balloon comes in range, and you're switching between one balloon to another without dropping the call. The balloons today can cover 5,000 square kilometers on the ground. You can get 15 megabits per second to your phone, or if you have a little MiFi device, you can get 40 megabits per second from the balloon.
So have you guys considered just selling this as like a toy for children's parties and stuff?
Yeah. I need the hanger to go with it.
Yeah. So Mahesh, tell me what it is we're seeing here.
So what you're seeing here is a test of our next generation balloon. We are doing a ground-based inflation, trying to mimic what is happening in space.
Mm-hmm. I remember when we were building balloons, it would take us a week to build them, and they would go up and pop and come back down.
When we first launched, it was pretty nerve-wracking. Our balloons were lasting anywhere from a day to day and a half, maybe 2 days. If you had like a 5-day balloon, it was like eureka. But as we went along, one of the first objectives was, what is our goal? Our target is 100 days, ideally, for us to have a very commercial business here.
I have a fashion design degree. It's a lot of working with textiles, flat patterns, working into three-dimensional space. We do a lot of different tests with balloons built in different ways. They might be a different shape, they might have an extra feature, we might change the dimension of a feature and try and figure out what works and what doesn't.
Rather than reinventing and starting all over from the start, we were looking for industries where we can actually leverage information from. One of the areas we looked at was food packaging industries, agricultural industries, even down to the condom industry. And so these are the places where we need to actually figure out even the tiniest pinholes that matter can actually limit the lifespan of the balloon by like 15, 20 days.
Our longest lasting balloon was up for 173 days until we brought it down. Now we've gotten to the point where most of the balloons will last over 100 days.
Done. Here we go, and we're awake. Ta-da! Don't put your fingers in there.
Yeah.
What you're seeing is a balloon inside a balloon. We have a unique way of actually adjusting the altitude in these balloons.
This balloon has a constant volume and there is helium in it, right? So the helium brings the balloon up. And now if we want to change altitude, we have another balloon inside the balloon that we fill with air. And as we add more air in there, the mass is going to increase and the balloon is going to go down.
Okay, this is called Hans. And we named it that because there was a Saturday Night Live skit, which was Hans and Franz, that's gonna pump you up. And what it does is it's a little fan and it pumps air into the balloon. It's easy to steer the balloon by picking up different winds and different wind directions at different altitudes.
By doing small change of altitude, you can do something like this. You go up, use this wind, then go down, use this wind, and go up, down, up, and down.
So this balloon has straps holding the apex up, and that balloon did not.
Right, which is why it's sitting down there.
Yeah, because yesterday when we were filling it up, it got in a twist to the point where it just did that. That's what happened. There you go. So we just popped the ballonnet because it was twisted. That was the test here.
Over the last 6 months, Google has run tests with Vodafone, Telstra, and Telefonica, utilizing their networks to provide connectivity to customers who normally live with little or no internet access. Loon believes that it can provide service to these remote regions at a fraction of the typical cost.
Communication satellites are typically pretty expensive, hundreds of millions of dollars to build and 100 million plus to launch, whereas the balloons are an order of magnitude or two cheaper to operate on a sort of daily basis. It's too expensive to build wires and cell towers and fiber optics out to all these remote rural regions, but the balloons are very cost effective. This gives the telco a way to reach everyone in their country with a cost-effective way.
Right now, Loon mostly operates in the southern hemisphere, where it's had better luck securing overflight permissions. But the project has potential applications for developed nations with widespread internet access as well. Because the balloons live in the stratosphere, they have a unique advantage over terrestrial internet infrastructure.
There's no weather in the stratosphere, which means if there's a hurricane or a typhoon that knocks out power or internet connectivity to people on the ground, even in places like Japan or China or other places around the world, the balloons provide a very exciting ways to immediately let people have connectivity 10 seconds after the natural disaster occurs. As long as they have a battery-powered phone in their pocket, people will be able to instantly get access to the balloon network. Sometimes people think of Google X as a research lab that's not necessarily a business, but that's not true. All of the projects on Google X have to have a business plan, a business case, and the business case for Project Loon is really exciting. It's still early stages in our project in terms of figuring out how big it can grow. It's great for bringing internet to 4 billion people on Earth who don't have it and bringing all the benefits, education, medical information, weather reports, but it's also a business in itself, a very good business. If many of these 4 billion people, even paying what they can afford, 1 or 2% of their monthly income, can now afford to have internet access, and it's a very good business in itself. Increasing the internet penetration by 10% in a country will increase the GDP by about 1.4% per year. So in many ways, technologies that can increase internet penetration of 10 or 20% can double the growth of standard of living of half the countries in the world.
It's a big thing.
Yeah, it is.
All right, let's get straight to this. Satellites are fake. Satellites don't exist. I know you guys are going to have a problem with it. I know you're going to grab your ergonomically designed keyboard, throw on your black gloves with leather patches with the tips cut off, put on a miniature gi around your index finger, and become a keyboard warrior. This is what you guys do. But I've been doing the research. You guys have been telling me that there is a Hubble Space Telescope taking pictures of stars. You've been telling me that astronauts are in the International Space Station. This is what you guys have been saying. Don't tell me you haven't been telling me this. Let's go into this thing here now. Now let's go into the layers of the atmosphere. We have the troposphere, stratosphere, mesosphere, thermosphere, and the exosphere. Now the satellites are supposed to be in the thermosphere. Thermo is dealing with heat. Now, how hot are we talking? Okay, well, according to Wiki Answers, the temperature goes from 600 degrees Celsius to 2,000 degrees Celsius. I don't know if you know how hot that is, but that's as hot as a blast furnace. We're supposed to believe that they have these machines in the thermosphere where the temperature goes up to 2,000 degrees Celsius. This is what we're supposed to believe. Some people might have thought that the higher we go up in the atmosphere, the colder it gets. Well, that's not the truth. According to them, it gets hotter, as we can see here. This is the troposphere, stratosphere, mesosphere. And then we go all the way up here. It gets hotter and hotter. So someone has to explain to me, how do you have satellites in the hottest layer of the atmosphere? I'll wait. Now, I want to just draw something here. As you can see, this is the ISS. It's from 330, somewhere around here, to 435. The Hubble Space Telescope is around 559 kilometers up. The satellites, they say, are from 120 to 35,000 kilometers, you know, all the way up. Guys, this is absurd. The melting point for steel, aluminum, titanium, gold is around 2,000 degrees Celsius. So they would be melting. If you really think of it, the satellites will become balls of flame. It will become a comet. They're moving at 17,000 miles an hour. And you have supposedly 26,000 satellites in space. This is what they said. But yet and still, they're telling us that we have things looking like this. Look at this. Does this look hot to you? This is gold, and come on, guys. This is ridiculous. Anywho, this is how satellites would actually look at the temperature that they're telling us the thermosphere is. They're telling us that thermosphere is from 600 degrees Celsius to 2,000 degrees Celsius. This is how it would look. This is how the Hubble telescope would look at 1,200 degrees Celsius. This is how it would look. This is how it would look from 500 to 1,000 degrees Celsius. Guys, this doesn't make any sense. This is a fantasy. Here you are telling me that you got satellites taking pictures. Just please send me footage of a satellite. Now here we have a blast furnace. As you can see, a blast furnace, the temperature is from 2,000 to 2,300 degrees Celsius. With a blast furnace, you create iron from putting ore into it, and then you blast it with air. This is how this is how the satellites would look if they were really in space, but they're not, because they're fake. They don't exist.
Have you ever seen what a satellite is supposed to look like? You have computer graphics to show you what they look like. And satellites are supposed to be past low Earth orbit. Look at how far GPS satellites are supposed to be. There's even satellites in an orbital state in geosynchronous orbit that are very, very far away from the Earth. So not only are you looking at computer generated images right now, you're looking at computer generated images of the Earth. When satellites are supposed to be past low Earth orbit, wouldn't it be kind of cool to have a real picture of the Earth for these illustrations? Satellites are supposed to be past low Earth orbit, and by now there should be thousands of pictures of Earth from space. Why would you ever substitute that for fucking computer generated crap? Why are billions of people okay with these images and the lack of photos of Earth from space? Why can't we have a real picture of the Earth that is not supposed to be a composite. Why can't we have that? NASA gets billions of dollars. Is that really too much to ask? Now here's an image of the Earth that people use all the time. It is not even supposed to be real. It's a composite, and it's been shown how this is made. And there's several images from this composite model that are presented as images of the Earth from space. They're not even supposed to be real. They don't pretend that they are real, but they allow you to think they are real. People use this image a lot. Where are the pictures of Earth from space? You believe these satellites exist. Why can't you give me pictures of the Earth from space? They're fucking right there. They're old technology. They can't take a picture of the Earth? Your beloved satellites that you believe and you'll defend till the end of your life? You have no problem with no pictures of Earth from space existing? And this image is important. That picture of Earth is from Apollo 17, and you're showing it your entire life, and they still show it in news articles today, and they're going to continue to show this image in the news for the following decades to come. They're never going to stop showing you this image to represent Earth. They're not even talking about Apollo 17 in these articles. They use that image, the same image, which is in every single science book, the same image which you've been shown your entire life. They're going to continue to use it in news articles in the future. This is 2014. You're probably watching this in 2015, and you're still going to see this image all year long, and you're not going to think about it. It's from the 70s. It's like something you would see on a poster in that 70s show. Remember their clothing? How ridiculous they look in that show? That picture of Earth can be on a poster in their room because it's from Apollo 17. It is that old. Here's that composite again. I typed satellites. I didn't type bullshit composite image of the Earth. Why does that come up? They even search for that. Look at all this computer generated bullshit. Are you okay with believing bullshit? Because I have a lot of family that are perfectly fine believing bullshit. They don't care that it's not true. They want to believe it. The cartoons your children watch today are so idiotic, and they're designed that way on purpose. They want dumb sheep that can't figure out the world around them. Your children watch cartoons, they're entertained by cartoons, and you believe that cartoons are real life. You believe that this shit exists. When NASA films their spacewalks, they're done underwater. There's even bubbles in the water. And the Hubble Space Telescope, which is supposed to be supplying you with data about the Big Bang, the universe, and galaxies and redshift, that does not exist in orbit because they performed these same fake spacewalks on a model of the Hubble Space Telescope. It is all fraud. There's that composite again. Even if you thought that was a real image of Earth from space, why would it keep coming up? Why one image? You believe in bullshit. Are you okay with that? Do you want to learn about the world around you? All you have to do is start looking at evidence. Just be like a detective. Think critically. Turn off the television. It is controlled. Learn about Freemasons and learn about the Jesuit order. This shit is history.
Now let's look at the contradiction, because if you actually start to watch this video, you're going to be interested. You're going to say, well, let me see if this guy's full of shit. You're going to jump on Wikipedia because that's the only source that you think is credible, and this is what they're going to tell you. Now, when it comes to the thermosphere, this is what they say. The highly diluted gas in this layer can reach 2,500 degrees Celsius during the day. Even though the temperature is so high, one would not feel warm in the thermosphere because it is so near vacuum that there is not enough contact with the few atoms of gas to transfer heat. A normal thermometer would read significantly below 0 degrees Celsius because the energy lost by thermal radiation would exceed the energy acquired from the atmospheric gas by direct contact. Now, if that's not a crock of bullshit, I don't know what is. I got a bridge to sell you. You know, does this even make any sense? So you mean to tell me that this layer of the atmosphere is as hot as a blast furnace, but it's actually not hot. It's actually below 0 degrees Celsius. This is what they're going to tell you. And now you're going to have to explain this to me. So before you come to me and tell me I'm crazy, before you come to me and tell me that I'm a troll and I'm looking for views, you're going to have to explain how the hell a layer of the atmosphere could be 2,500 degrees Celsius, but actually 0 degrees Celsius. Because if that's the case, then we shouldn't feel the heat from the sun. Because according to them, the sun is far out in the space. It's far out in the vacuum. So you have to explain to me, how do we feel the heat from the sun? Someone has to explain this. I'll wait. I'll wait for someone to explain this, because I know you guys are geniuses, you guys are intellectuals that's watching this video, you guys are smarter than I am, right? So you're going to have to explain to me how we feeling the heat from the sun, but here we have a layer of the atmosphere that's supposedly hot, but because it's in the vacuum, it's not hot. I'll wait for the explanation, because I know some of you guys are Einsteins, I know you guys are prodigies, you guys are nerds, right? You guys are so smart. So I'll wait for this explanation. Let's move forward. Now we're going to look at these melting points, because this is really what kind of shoots down the theory of satellites in space. Now the melting point of titanium is 1,668 degrees Celsius. The melting point for aluminum is 660 degrees Celsius. The melting point for gold is 1,064 degrees Celsius. But we have satellites made out of these three elements, flying in space at 17,000 miles an hour, where the layer that it's flying in is from 600 to 2,500 degrees Celsius. You guys have to explain this, because I know you guys are going to have a problem with this video. You're going to call me names, I know it. But you have to explain to me how we have satellites in an atmosphere that's up to 2,000 degrees Celsius, but all the elements that it's made of can melt at 1,000 degrees Celsius. And now here's a picture of the Hubble Space Telescope. This is in the friggin' thermosphere, and this is how it looks. You guys have no problem with this. And of course you have rocket propulsion. Now, I didn't even write any notes for this one, because this one is so ridiculous. So you mean to tell me they're using rockets in space, but they said that in space is a vacuum? How are you pushing against nothing? It doesn't make any sense. Alright, let me give you an example. Let's say you have a boat. Now with the boat, you have the oars or the propeller. The propeller or the oars are pushing against water. Let's say you take the boat outside of the water, and you're still, pushing the propeller or spinning the propeller, and you're still, rowing the boat. You're not going to go anywhere. That's the same principle for rockets. In the Earth's atmosphere, you have an atmosphere to push against. So when you blast a rocket, you'll go forward. But when you're in space, according to them, they say it's a vacuum. So how the hell are we seeing satellites with this? How are we seeing satellites with this bullshit? Someone has to explain what type of propulsion system they're using, but they're telling us it's satellites, because this is the picture. This is a NASA photo. This doesn't make any sense. This proves even further that these satellites are fake. These satellites don't exist. And now they have, what's this? Solar panels? So you mean to tell me that they are more environmentally conscious in space than they are on Earth? Are you serious? So they don't have solar panel cars, but they have solar panel satellites. It doesn't make any sense for them to all of a sudden be so conscious. But that's besides the point. But my main point is, this rocket propulsion in space is ludicrous.
Now, how many satellites are in orbit? You can't get a number, but that number will range from anywhere between 1,500 to 20,000 satellites. You'll always get a different number as to how many satellites exist in orbit. What do satellites look like? The old satellites from the 70s were very large. The Navy even recently had an operation where they pretended to shoot a satellite out of orbit to minimize its danger in re-entry, and they described this satellite as being the size of a bus. Satellites used to be quite large. Nowadays, they want you to believe that satellites can fit in the palm of your hand. Now they have CubeSat satellites, and they can they can be deployed from the International Space Station by hand. An astronaut can toss one of these CubeSat satellites at the Earth. Doesn't even matter how he throws it at the Earth. You could throw it at the Earth or towards an orbital plane. It really doesn't matter. It doesn't matter that you toss it and it's tumbling uncontrollably, but this is what they'll have you believe.
I'm telling you now, there are no satellites up in space. All the information is gathered from the ground, so there's no need to have satellites floating around in space taking images, because NASA just aren't putting them up there. And then people always say, "Hey, what about the weather satellite images then? How are they getting them?" It's quite simple. They use ground-based radar to take measurements of the weather, and they put these predictions into a computer, and it gives them these animations, and that's all they're showing you, and the weather forecasts. And then they put as if you're looking down from above, so they put the land, they superimpose the Earth behind the radar data. That's all it is. None of the images you're showing are real photos from satellites up in space. They're just images, predictions from radar, and then they superimpose the information onto the background of the Earth, so it looks as if you're looking down from above. And that's all it is. There are no satellites up there. Trust me. So explain this to me, when you've got all this space junk apparently floating around the Earth, how are they taking these images and not picking up all this stuff? And there's supposed to be 20,000 satellites floating around the planet. I mean, look, this is what they reckon's up there. So how can all these satellites be taking images and never catching any of this stuff? All this space junk in the way. The same with the Hubble. Okay? That's all it is. There's nothing up there. There are no satellites.
Everyone knows all about my direction. And in my heart somewhere, I wanna go there. Still I don't go there. Everybody says, say something, say something, say something, say something, say something, say something. I don't wanna get caught up in the rhythm of it, but I can't help myself. No, I can't help myself. No, no. Caught up in the middle of it. No, I can't help myself. No, I can't help myself. No, no, no. Caught up in the rhythm of it. Maybe I'm looking for something I can't have. Maybe I'm looking for something I can't have. Everyone knows all about my transgression. Still in my heart somewhere, there's melody and harmony for you and me tonight. Whoa, I hear them call my name. Everybody says, say something, say something, say something, say something, say something, say something. I don't wanna get caught up in the middle of it, but I can't help myself. No, I can't help myself. No, no. Caught up in the middle of it. No, I can't help myself. No, I can't help myself. No, no, no. Caught up in the middle of it. Maybe I'm looking for something I can't have. I'm looking for something I can't have. Maybe I'm looking for something I can't. I'm looking for something I can't. Maybe I'm looking for something I can't have. Maybe I'm looking for something I can't have. Maybe I'm looking for something I can't. Maybe I'm looking for something I can't have. Sometimes the greatest way to say something is to say nothing at all. Sometimes the greatest way to say something is to say nothing at all. Sometimes the greatest way to say something is to say nothing. 1, 2, 3. But I can't help myself. I can't help myself. No, no. Caught up in the middle of it. No, I can't help myself. I can't help myself. No, no, no. Caught up in the rhythm of it. Maybe I'm looking for something I can't have. Maybe I'm looking for something I can't have. Maybe I'm looking for something I can't have. Something I can't. Maybe I'm looking for something I can't have. Maybe I'm looking for something I can't have. Maybe I'm looking for something I can't. Maybe I'm looking for something I can't have. Sometimes the greatest way to say something is to say nothing at all. Sometimes the greatest way to say something is to say nothing at all. Sometimes the greatest way to say something is to say nothing.
Just briefly show you how they generate a picture every 10 minutes with what appears to be accurate in current weather. This is basically what they do. Now, don't take my word for it, as I always say. Go check it out for yourself. Number 1, they have already created and stored transparent images of the weather over the oceans using climate simulation software, which they openly admit right here that they've done climate simulations up to the year 2095. But it's actually the year 2100 on this FTP server folder, and here's one of the images. And following some of the other images that you can find where the land masses are transparent, and they use all this simulation software to come up with the weather over the oceans. You know, since our weather data comes from our ground-based Doppler radar, and it's impossible to use ground-based systems to cover the entire vast oceans, so that's where the weather over the oceans comes from, their software simulations. Number 2, now for the weather over the land, the NOAA has supercomputers that take data coming in from all over the world, Doppler radar feeds, and crunch it it all together and combine it with the weather simulation data over the ocean, so they come up with a complete composite weather quote-unquote map, which is then wrapped around a ball in their 3D modeling software programs, just like we've shown countless times in our previous episodes with the Earth and the planets, etc. So then what we get are composite images like this that are created in the 3D modeling software, the current Doppler weather data over land and the simulated weather over the oceans, and it looks like this. So this particular image is on the FTP server and is date and time stamped with October 11th, 2017 at 11:05 a.m. I just chose one randomly. Notice the image shows you the weather for the whole ball and not just part of the ball that is lit by the sun at this particular time. No Terminator line or anything like that, right? Okay, now here's the kicker. Go to the other file folder, which is the images that we get to see and are told are real pictures from space. But what they've simply done is taken the weather map picture of the whole ball they created and they superimpose it over the blue marble data set, just like they said they did. So what you can see here is the final version of what we're spoon-fed and told is a picture taken by the Himawari from space, like, 10 minutes ago. This is the image from the same date and time, October 11th, 2017 at 11:05 a.m. And you can see that the weather is exactly the same. Watch it closely. There's your weather map comprised of simulated and Doppler radar being used to complete a composite image. They do this with the Discover satellite too. The Epic camera from 1,000,000 miles away, they tell us. Ridiculous. Okay. Now, also notice the final image has a Terminator line added in to try and make it look like a real picture from space, which drives a nail in the coffin of the Himawari because the weather data shows it over the whole ball completely. But they have to add a Terminator line to show the Earth only partially lit by the sun based on the time of day that the photo is allegedly taken. So if this is a real picture, how did they know where to put the clouds and weather on the part of the globe with no sunlight? It's completely dark there. It's all right here, guys. They are faking space. Hey, we all fell for it for a long time with their Doppler radar and weather simulation software building a current weather picture and wrapping it around a ball in 3D software and pasting it onto a black background like they do with all the others, adding a Terminator line and calling it a real picture from space. Himawari debunked once and for all. This has been Paul on the Plane. Thanks for watching.
Positive rates. Gear up. Gear up.
On our way today to New York, we will cross the Atlantic Ocean, and there's limited or no radar coverage from ATC. That's why we followed, let's say, highways in the sky, and all the aircraft are separated from each other 10 minutes, so we have to fly a fixed speed over the ocean. And they are chosen in such a way that they are most economical. On our routing today to New York, we try to prevent the headwinds, and so at this time the tracks are very southerly to prevent the 200 knots headwinds northern part of the Oceanic. In a minute we're going to request the clearance from ATC for our track today to New York. So what we do is we select here Oceanic clearance request. Flight number is automatically put in. The flight level. That's the flight level for the crossing. That's flight level 360.
360, yeah.
Speed that we have to fly. Set.
Yeah, check.
Okay. There's the clearance. KLM 641 is clear to Kilo Juliet Fox of Kilo. That's New York via Sepal. Not Delta. Sepal.
Checked.
And then 4615.
Checked.
4520.
Checked.
4330.
Checked.
4240.
Checked.
4250.
Checked.
4260.
Checked.
Dovi.
Checked.
Maintain flight level 360 Macron, decimal 85.
Checked.
So we accept that message. And then we have again that our confirmation is received on their side. So they now know that we have received the clearance.
KLM 641 Heavy to send, maintain 7,000. 7,000. KLM 641 Heavy contact final 132.4 today.
1324, KLM 641 Heavy. Goodbye.
Flaps 1.
Flight 1. Kennedy Tower, KLM 641 Heavy and 04 right.
KLM 641 Heavy, Kennedy Tower 6 miles bound and Airbus 320, wind 36017, gust 28, runway 4 right, clear to land.
Clear to land, 4 right, KLM 641 Heavy.
Glide slow. Gear down.
Gear down.
Flaps 20.
Flaps 20.
Speedback's on.
12 knots crosswind left.
100, 50, 40, 30, 20, 10.
Speed back up. Reverse normal.
Operating 24 hours a day, numerous nations maintain a network of LORAN transmitting stations to service the major shipping lanes. There are a pair here, for example, Sisconsit and Bodie Island. One is known as the master station, the other is the slave. For a moment, consider these two stations operating as a synchronous pair, simultaneously emitting short pulses of radio energy. Leaving both shore stations simultaneously, a pair of pulses travel out into space, in all directions, at a constant speed, roughly 186,000 miles per second, or the speed of light. Plus, the pulse from the closer station will reach the ship an instant before the pulse from the other station. The LORAN ship board gear measures this difference in time of arrival in millionths of a second, or microseconds. It simply determines how much longer one pulse takes to reach the ship than the other pulse. Now, this same time interval will be observed at many points within the range of the two shore stations. And when connected, these points form a hyperbola, known as the LORAN line of position. To aid the navigator in obtaining a fix, specially prepared LORAN tables and charts contain accurately plotted lines of position on the various time differences encountered in a particular area. Having one line of position, we then obtain readings from another pair of stations. An accurate fix is established at the intersection of the two lines of position.
An agreement has been reached which paves the way for the creation of a global tracking system for commercial aircraft. At a UN telecommunications conference, countries decided to reserve satellite radio frequencies so planes can be tracked from space as well as the ground. The deal follows the disappearance of the Malaysia Airlines flight in March last year, which exposed flaws in the system, as our correspondent Theo Leggett explains.
Current methods for tracking aircraft depend on radar, which has a limited range, and a radio system called ADS-B. This allows an aircraft to broadcast signals to ground stations, which can then be used to calculate its position. However, the system doesn't work if there are no ground stations in a direct line of sight to the aircraft. As a result, planes cannot be tracked over oceans or in very remote areas such as the polar regions. The loss of MH370 and the subsequent mystery over its whereabouts highlighted the need for a better mechanism. Under plans being drawn up by the International Civil Aviation Organization, satellites will also be used to pick up ADS-B signals, enabling aircraft to be tracked continually around the globe. The allocation of radio frequencies is the first step. More satellite infrastructure will also be needed, but the organization hopes the new system will be in place within the next few years.
We never stop hearing about how the internet's in the cloud, but really, it's in the ocean.
About 300 undersea fiber optic cables are responsible for 99% of international data traffic. It's basically the same way we connect to each other in a single country, except underwater instead of underground. They transmit PewDiePie from Europe to America, and they connect stock traders in New York and London. And these cables, placed by private companies, are the backbone of the internet. But if you held one in your hand, it'd be no bigger than a soda can. There are just a few layers of protection from the water, including petroleum jelly. Yes, your internet is covered in Vaseline. They're vulnerable to earthquakes. At least a few times, confused sharks have bitten them. But many cables are beneath sea life because in some places they go as deep underwater as Mount Everest is high. Ships lower a plow that digs a tiny groove in the ocean floor, lay in the cable, and it's naturally buried by sand, thanks to the ocean's current. And that process, it's both stunningly simple and mind-blowingly complex, is responsible for making the internet a truly global network. It's an idea that's audacious and crazy, and you think it has to be cutting edge, and it is. But it's also been going on for 157 years. Electric telegraphs have been around for a long time. Experiments in the early 1800s connected two ends of a garden using a clock that revealed letters. Then they moved on to two neighborhoods to help signal trains, and then multiple cities thanks to a network of railroad lines. Underwater submarine cables were an obvious next step, so they played around. Instead of petroleum jelly, the first ones were coated with exotic tree sap to protect them from the water. And though the undersea cables came in spurts, one of the first ones was knocked out of commission by a fishing boat. By 1858, they reached around the Atlantic and across the world. And that's how it's kind of gone since, laying cables that circle the Earth's oceans. The cables are unwound from the back of the ship, sink to the ocean floor, and the world is connected in speeds measured in milliseconds. There are ideas to bring the internet above sea level. Along with cell phone towers, there's internet beamed from Facebook satellites to Africa and balloons lifted by Google. But for speedy international travel, undersea cables are still where companies like Facebook and Google place their bets. That's because the best way to create the cloud is still by going under the sea.
Hello wonderful person, this is Anton, and today we're going to be talking about this really exciting project known as Superbit. A project that might help us replace the aging Hubble telescope, and a project that might allow us to create a lot of telescopes with extremely powerful observational techniques. A project that's been in the works for the past 5 years or so. But it's not going to be a space telescope that's going to require a lot of planning and a lot of funding. It's actually going to be a telescope using a brilliant design from NASA. Using a balloon. Something that NASA has been thoroughly testing for the past 5 years, and something that has already successfully been tested. But the new implementation, this telescope right here, known as Superbit, is so far the most exciting. This is literally something that could one day replace Hubble. And so let's talk a little bit more about this and how all of this works. But first, here's what it already was able to achieve. This beautiful picture of the pillars of creation, even though it might look like it was taken by Hubble telescope, was actually taken by Superbit. And this is around 3 years ago when the mission was just testing its capabilities. Since then, the international team from Durham University, Toronto University, and Princeton Universities have successfully teamed up with NASA and Canadian Space Agency to make this a reality. They officially are planning to launch this mission and to have it work full-time in April of 2022. Which also means that we might enter a completely new era of space observation. And so first of all, this is an entirely new kind of an astronomical telescope. Unlike a typical ground observatory that's usually located somewhere in Chile, somewhere on top of the mountains, mostly because there's less atmosphere there, or the typical commercial telescopes you might have at home or might be able to purchase in a store, Superbit has one main advantage. It does not have to deal with atmosphere. As you probably know, by looking at, for example, our own moon from planet Earth, you typically have to deal with a lot of different air turbulence. And this of course creates a lot of difficulties if you want to have a really sharp picture of some sort of a distant object. Here's for example different types of turbulence influencing the observations of the nearby Sirius A. And so because of this, modern telescopes either are built really high up where there's less atmosphere, or become really expensive space observatories. But both of these naturally have a lot of problems associated with them. For one of them, it's the location. It's kind of difficult to travel back and forth from a region somewhere far away. And with the other ones, the ones in space, it's usually the inability to upgrade them, and of course the actual costs associated with not just launching such telescopes, but also designing them to be able to survive in space for years and possibly decades. And even though Hubble telescope was designed to be upgradable and modular, because the space shuttle mission has now been cancelled, as you probably have learned from one of the recent videos, it's just a matter of time now before the Hubble telescope fails permanently. In a few years, when the cameras get really good and also when the lenses are improved quite dramatically, eventually this might even become a larger instrument and a more capable instrument than the Hubble telescope.
It's the coldest, driest, highest, and windiest continent on Earth. Despite its reputation for the fiercest weather on the planet, Antarctica is a hotspot for scientific ballooning. The reason is Antarctica's circumpolar winds.
Cool. That was awesome. That was awesome.
These high stratospheric level winds set up during the Antarctic summer and circulate around the South Pole in a counterclockwise direction. This means NASA's giant scientific balloons, the largest being nearly 40 million cubic feet, can be launched, ascend to 120,000 plus feet, the edge of space, and sail the circumpolar wind around the continent for 10 to 20 days on average. And in some of the most successful instances, flights can be terminated and the balloon and payload recovered. All within 100 miles of where they were launched. Riding this Antarctic vortex in 2008, a 7 million cubic foot super pressure test balloon flew for 54 days, setting a stratospheric scientific balloon flight duration record. Scientific ballooning operations here on the ice are the result of a unique partnership between the National Science Foundation and the NASA Balloon Program. NASA funds the science, and NSF provides the support to scientific teams and their balloon-borne experiments. Like this one called STO, or the Stratospheric Terahertz Observatory. It's being readied for its first Antarctic summer flight at the NASA NSF Long Duration Balloon Facility at Williams Field. The LDB launch facility is located on the Ross Ice Shelf, a 45-minute drive from McMurdo Station, when the weather's favorable. STO is designed to address a key problem in modern astrophysics, which is understanding the life cycle of star-forming molecular clouds in our Milky Way galaxy.
What we're doing is looking at specific emission features from carbon and nitrogen atoms out in space within our own galaxy.
In doing so, STO will map a swath of our galaxy with the world's most sensitive high-frequency radio receivers, essentially listening in to how clouds of gas and dust, which permeate the Milky Way, coalesce to ultimately spawn stars and planets.
But for instance, no one's actually ever captured a cloud, one of these molecular clouds in the process of formation. No one's been able to see that.
One reason is these atoms and molecules radiate at such a high frequency, over 1,000 billion cycles per second. Too slow to be observed with the human eye, but too fast to be observed through the blanket of water vapor that envelops the Earth's surface. With STO, primary investigator Chris Walker and his multinational team have developed a way to capture and focus this far infrared light using a conventional optical telescope on a high-altitude balloon platform that flies far above most of the Earth's obscuring water vapor.
The light comes in, hits this mirror, goes up to a secondary mirror, and then sends it back through a hole in the bottom of the telescope. It comes right out the bottom of that telescope.
From there, a secondary optic system channels the far infrared light to superconducting detectors held within 5 Kelvin of absolute zero inside a liquid helium-cooled dewar. The telescope and the dewar, Walker is proud to point out, are recycled components.
And the original telescope was built, the way I understand the history, for flying on the space shuttle, but it never flew. And so it was actually in a warehouse at the Smithsonian, I was told.
And the cryostat was a prototype to cool instruments for the Spitzer Space Telescope.
We put the two together, and we really have a space-grade instrument that we're flying on a balloon.
Walker is equally savvy about how the economics of scientific ballooning can help further his team's science.
Oh, it's a huge significant stride forward. The main reason is when you compare balloon flights to space flights, you're limited in the size of your payload and the amount of power it can take. You're usually limited to an instrument that weighs a couple hundred pounds and takes a couple hundred watts. But with the balloon, you can actually fly much larger instruments that can look at a whole bunch of more of the Milky Way or extragalactic space than you would normally. In the end, you can do more science than you could from orbit at a much smaller price.
STO was successfully readied and launched on January 15, 2012. Carried aloft by a conventional 39 million cubic foot zero pressure balloon, the STO flight lasted for 14 days, completely circumnavigating Antarctica. The mission allowed extensive testing of many flight systems to be conducted. STO was successfully terminated, recovered, and reconfigured to fly again in Antarctica on December 9, 2016. The STO-2 flight lasted for 20 days, circumnavigating the continent twice. The mission verified the operational capability of advanced flight systems critical to the next generation of terahertz balloon-borne observatories, GUSTO. GUSTO will map the interstellar medium between 4 and 8 times faster than STO-2 and do so for 5 times longer, allowing a significant fraction of the Milky Way and all of the Large Magellanic Cloud to be surveyed in a single flight. It's an example of a new class of sophisticated science payload designed to take advantage of the revolutionary capabilities of NASA's new super pressure balloon platform, designed and engineered to keep science payloads aloft for 100+ days.
So the cutting edge of science is independent of the tool you're using to advance the science. There are still compelling science questions which can be answered on balloon platforms, and since balloon platforms are the most cost-effective way of going after these really important science questions, that's the way we should do it.
the new scientific ballooning capabilities are offering us is a technology. Okay? It's an enabling technology to get us to the edge of space, scientifically meaningful, for a longer duration at a reasonable cost. That's the technology. The need is there's lots of great science to be done that we can do on these platforms at lower cost and get the important training to be able to test out instruments. We may test out things that are very high value on a scientific balloon in anticipation of a future flight opportunity. And so now we've met a need with the technology, and that's real innovation. That's when NASA makes progress.
Why we don't give, why we don't try. Blame you for the fiction skies with your deep space lies, but the truth will rise. Don't see no real satellites. Yeah, we believe what they said too soon about the stars and the moon. In a rush for the truth, we believe with no proof, lost in the romance. We must ask why. And did they think it was fine to let us think we're less than divine? Whoa, whoa. We know you've never reached the moon, that it's all cartoons, that it's all just skies. We hide and we accept their lies, but we must see why we need to rise. Don't see no real satellites. Now we lost what it means to be true. Are you sure that it's you? If you could open your eyes, you would see we've been fooled. Don't wonder why. Just open up your mind so you can see the world's greatest deception ever. We know now that the earth's not round, that it don't spin round, 'cause the truth's been found. We know now that they can't exist, though your shots just missed. What a perfect twist. Don't see no real satellites. Now when you look to the stars and the moon and Mars, you need to know what they are to understand this concept. Don't pass it by. Take a shot in the dark, hit the mark, rejoin man's greatest adventure. Whoa. I blame you for the way we live, why we don't give, why we don't try. We know now that they can't exist, that it's all just myths, so your shots just missed. Don't see no real satellites. see the world's greatest deception ever. Blame you for the way we live, why we don't give, why we don't try. We know now that the earth's not round, that it don't spin round, 'cause the truth's being found. Don't see no real satellites.
This world is not what you think it is. This world is not what you think it is.